For those of you who don't know me, my name is Megan Vandermill. I'm a math professor here at GRCC, and I am particularly interested in areas of math that kind of overlap with politics. So in particular, redistricting, so how we draw district lines to determine, how we're grouping people to select representation. Voting systems, how are we gathering preferences of different voters to decide a result that's going to affect all of society. And then apportionment. So if we have a select amount of seats and we want to decide how many states or how many seats each state is getting, how do we best decide that? So all of those are kind of related to taking a really large group of people and distilling all of the values, the ideals, the preferences of that large group into a very small thing, either a number of seats, a person that's going to represent them. So how do we translate that large group of things into a very small thing in a way that's as fair as possible? So today I decided to focus on voting systems. So we're primarily going to be looking at different voting systems. And if you've taught our Math for Liberal Arts class or been a student in our Math for Liberal Arts class, you may have seen this before. We do teach it. This is kind of a common thing to teach in like quantitative literacy type courses. But other than that, you don't really see it in a math course. So even for myself, I never saw this. I got to grad school before I started seeing this. And it was just because I saw an article and I thought it was interesting and I looked it up. But it's not a common part of the curriculum, which I think is too bad. So I thought, well, let's do a seminar on it and talk about it. Okay, so I've got a kind of this is more a thought experiment than a realistic situation, but go ahead and read the scenario. So you're a manager, you've got a team of 9 people that are looking to hire someone, and you've got 3 candidates, okay? And let's say that this is the information that you're given. So these are the 9 people that are part of your hiring committee, and they're just gonna give you their first choice candidate. So if you're given this information, what candidate do you go with? A. Why A?
First choice.
Most often.
Okay, so A has how many first place votes?
4.
4. B has how many?
3.
And C has 2. So this is all I have. Let's just go with A, right? That's if I don't have any other information, then that's what we're going to go with, right? Okay, what if this is the information you're given? What candidate do you go with then?
Right, only one person voted.
So, well, you don't know what anyone else thinks. All you know is what Phil thinks. But that's all the information you have.
Sounds like you need 18 employees. You have to vet Phil.
This is why I said it's a thought experiment rather than reality, because we're assuming we'd get more information than this. But we're going to have to go with A, right? Because that's all. We know at least one person likes A. We don't know anything else. Is that going to be the best hire?
Maybe, may not be.
Yeah, I don't know, right? It doesn't give us a lot of info. Okay, what if you have this information? Take a minute to look at it. I know it's a lot of letters.
It's hard to make decisions. You have to give them points to count all points for each
Okay, how do you want to do the points? What are you
Well,
thinking?
you can do it backwards. Number third get 1 point.
Uh-huh.
Number 2 get 2 points. Number 1 gets 3 points.
Okay.
Then you can count the number of total points and see who wins.
Okay, so I could give points, right? 3 points for first place vote, 2 points for second place vote, 1 point for last place vote. Okay. Anyone else have another way of looking at it? Another thought or first impression?
Could discard 3. I mean, that's a little harsh, but, and pointing out that B is everybody's first or second choice.
Okay. So so before when we just see this, right, A has the most first place votes, but as soon as we see second and third choice, that paints a little bit different picture, right? Because now we see that in general, everyone kind of likes B, right? It's either their first choice or their second choice. But what do you see when you look at the third choice row? Yeah, A is actually ranked last the most number of times, right? A is ranked last more than it's ranked first. So this gives us a whole lot more information than we would have if we were just looking at the first row, right? Okay, so I'm going to go back to this one. This scenario is analogous to a voting system that we all know. It's the system that we use in the US for most of our elections, which is called plurality or first past the post. It's not a majority, so a lot of times we think it's majority rules, but it's not, because you don't have to get a majority in this system, right? Because does A have a majority here?
Yeah.
So when we say majority, we mean at least half. So we've got 9 people. How many votes would we need to get at least half? We need 5 or more, which A does not have, right? So if I have more than 2 candidates running, it's actually kind of difficult to get a majority, right? So in this system, we're not really likely to get a majority. The other thing is it just doesn't give us as much information, right? So we saw that with looking at the additional 2 rows, that there's some information that we're not seeing. The other thing I wanted to point out here is if I look at this, if you are Mark and you know that candidate C is not that popular, and all you're doing is submitting your first choice, what would probably be a better way for you to vote? If you're just submitting your first choice.
Pick B and A.
Yeah, so if you're Mark and you know C probably doesn't have a chance of winning because no one really likes C, who's your next best option? B, right? And you know that B maybe has a chance of winning, so I'm going to vote for B instead. Even though that's not my first choice, it's probably better. I'm going to get a better outcome if I vote for B rather than C, right? That's called insincere voting. So I would be voting in a way that doesn't match what my preference is, because I'm trying to get the candidate that has the best chance of winning, I'm going to vote for them, not the one that I like the most. Does that make sense? Okay. All right, so this is plurality or first past the post. This is an actual voting system too. Does anyone know what it is or have a guess as to the name of it? What was that?
Us. Most people stay home.
This is called a dictatorship. So a dictatorship, and this is the technical word for it. If you have a voting system where you're basically blind to everyone except for one person, and you just take that person's first place vote, that's a dictatorship. Which obviously has a lot of problems too, right? Okay, so this situation where I have a ranking for every individual voter, there's actually a lot of voting systems that I can use for this. And it's because I have a lot more information. So there's a lot of different ways that I can use that information. So what I want to do next is look at some of those different ways we can use it. There are way more voting systems than what I have up here. I just put a couple common ones up here. And I kind of group them into similar groupings. So let's see if this works. This board account score voting is related to giving points. So we'll look at that one first. And then we've got I don't know if it's Combs or Coombs, but this method and then ranked choice voting are related to aiming for a majority, and if you don't get a majority, eliminate until you do get a majority. And then these ones, pairwise competition, sequential pairwise voting with a fixed agenda, those ones are related to taking one candidate versus another candidate one-on-one and comparing how they do to each other. So we'll look at some examples of these. So does this look familiar? Yeah, this when I teach this in math for liberal arts, or I teach this with middle schoolers sometimes too. If I give them a table like this and don't give them any other information, I just say, like, decide what the best option is, 50% of them come up with some point system. So I feel like the board account tends to be the most intuitive one that we tend to jump to. So let's try doing it. So if you have a piece of paper and you wanna, or on your phone, you wanna tally them up, see if you can figure out who would win if we score it this way. Anyone need another minute? Okay, so that should be the score. Does that look right? So B would win. B would have 21 points. C and A are pretty close to tying for second, 17 and 16. Now there's a lot of different versions of board account. You could weight it so that a first place choice gets more than 3 points. NBA, MVP is decided using a board account type system. So the way it works is, and I believe this is just fans casting votes online, but the first place vote gets 10 points, second place vote gets 7, third place vote gets 5, fourth place vote gets 3, and then fifth gets 1. So you can vote for 5 players. So it's kind of like it's weighted differently, but it's a board account type system. Plurality is basically board account, where the first choice gets 1 point and everything else gets 0. Right, so it's kind of a simplified version of board account. Okay. Pairwise comparison systems pit 2 candidates one at a time. So the way you do this is I'm going to start with A versus B. And what I'm going to do is look at each column and I'm going to ignore C. So if I have Phil, who does Phil prefer? A. Phil likes A better, right? Ahmed likes B better, even though C's in the middle, right? B is higher than A. What about Mark? Who does Mark prefer? B, right? Yeah, even though B is not their top choice, it's higher than A. So all I'm doing is looking and comparing what's on top, B or A. So if I do that, this is too high for me to write on, so I'm going to do it over here. So A versus B. So let's see, 1, 2, 3. I think A gets 4 and B gets 5. Does that look right? Okay, try doing B versus C and then A versus C. See what you get for those two. We good? Does that look right? Yep. Okay, so there's a bunch of different pairwise comparison systems. So the classic one is where you say, okay, if you win a competition, you get a point. If you tie a competition, you get half a point. In other words, you get 0 points. So in this case, B would get 2 points because B won twice. C would get 1 point because C won once, and A would get 0 points. This one can get clunky if you have more than 3 candidates. Like if you have 5 candidates, you'd have to do 5 choose 2 competitions. That would be 10 head-to-head competitions. So it can be a lot. So another version of this that is sometimes easier to do in the classroom is, like, let's say I have 5 candidates. You can do what's called sequential pairwise comparison with a fixed agenda. So what you do is, instead of having everyone go against everyone else, I have A go against B. And then the winner of that moves on and the loser is knocked out, right? So in this case, let's say A loses. So then I next have B go head-to-head against C. So let's say B wins. And then B goes against D. And then let's say they tie. So if they tie, then they each go against E. And you stay in basically until you get knocked out. Okay. So that's...
Does the sequence affect that?
Yes, it definitely does. It definitely does, yeah. Because it's going to be better to be at the end, right? Because you're not playing as many games, right? If you're here, A would have to beat every single candidate in order to win, whereas E just has to beat whoever beats D, right? Okay. So anything where you're doing those head-to-head competitions, there's a lot of different voting systems that do that, but that's what we mean when we talk about pairwise type systems. Okay, so then we have elimination systems. So for these ones, we're looking for a majority of first place votes, which we already talked about that we don't have that yet, right? We have 4 first place votes. I need 5 to get a majority. So if there isn't one, then you eliminate the candidate who's doing the worst. Now, your definition of worst will determine the voting system you're using. So there's different voting systems depending on how you define what's the worst, right? So any thoughts about what might be one way you could define the worst candidate?
You could say whoever has the least number of first place votes, the most number of last place votes.
Exactly. Those are kind of the 2 classic ways of doing it. So the first one, where I say who has the least first place votes, the least number of first place votes, that is called instant runoff. And this is the most common elimination type system. It's also called ranked choice voting. It's also called plurality with elimination. And it's sometimes called the Hare system. H-A-R-E, probably named after someone. Those are all the same thing. If you are in a math textbook, you're more likely to see instant runoff or plurality with elimination. If you are in the political sphere, you're more likely to see ranked choice voting. But they're all the same. So the way this one works is I'm going to look and see what's the least number of first place votes. In this case, it's C. So I'm erasing C. It's like C was never a candidate in the first place. So C gets knocked out. And then what happens is Mark and Tim's first choice is now B, right? So A has how many first place votes? 4. B has 5. So that's a majority, right? We said as soon as you hit 5, we've hit a majority. So B would win. So we've hit this majority. Coombs' method says look at the last place votes. Is there no eraser in here? There's one over here. Thanks. So I'm gonna eliminate based on the most last place votes. So in this case, who would that be? A. So then it's like A was never there. Okay, so anyone that had A as a first place vote, now I think all of them have B as their second place vote. So then B has 7 and C has 2. So B hits the majority, so B wins. All right, so that is, uh-oh. Nope. Try again. Okay, I won't touch it. Let's see if that stays. All right, so that's kind of our summary of voting systems. There are way more than that, but those are kind of the basics. I did want to mention score voting and approval voting. So these are systems that they don't use ranked choice voting, so you're not ranking alternatives, but you are. So in score voting, for example, maybe you're given 10 points and you can distribute those 10 points however you want to the candidates. So if you have one candidate that you really like, you're going to give them all 10 points and everyone else 0. If you're kind of neutral about all of them, maybe you give 2 points to 5 candidates, right? Another version of that would be if you have 10 candidates and each of them you're giving a score of 0 to 10. Right, so instead of distributing a fixed amount of points to all the candidates, every candidate you can score from 0 to 10, so you could have them all tie. You could have, all of them 0 except a couple. If you really think they're all terrible, maybe they all get 1s. So those are variations of score voting. But you can have ties, right? So it's different than what we've been looking at before. Approval voting. That's where you either give every candidate a yes or a no. So there's not ranking involved. And the candidates with the most number of yeses wins. So I just wanted to share those to show you that the world of voting systems is very large. And this is just a small portion of what is possible and what is used. Okay, so this leads to the question, which voting system is best? Right? What do you all think? Anyone have thoughts about that?
What does best mean?
Okay, what does best mean?
The cheapest, the most accurate?
Yeah, so there's a lot of ways to decide what do we value in a voting system. So I'm going to show you a couple mathematical ways that we can evaluate voting systems. We've already kind of talked about how plurality and dictatorship don't give us as much information to work off of, right? We've already talked about that a little bit. But I'm going to show you two. So there's a bunch of different fairness criteria, and I'm going to show you examples of two of them, okay? So we're going to start with this one. So there's a slight difference between these two preference profiles. See if you can spot it. Does anyone see where they're different? Yep, the last column. So the last column here, we've got BAC, and the last column here, we've got ABC. So which of these is better for A? The first preference profile or the second preference profile?
Second one.
Second one, because A's the same here and here, but higher up here, right? So this one is better for A. Erase this. All right, so now what we're going to do is find the winner using ranked choice, so instant runoff for each of these. Okay, so let's look at the top one. Do I have anyone that has a majority? Is there an alternative that has a majority? So there's 17 voters, so I would need 9 first place votes. No, so I have to eliminate, so who gets eliminated? I actually have 2 that tie for the least first place votes. So in that case, we eliminate both. So C and B both get eliminated. So who's the winner? A. Okay, so in the first one, A wins. Okay, let's try the second one. So do I have a majority? A is close, but there's only 8 first place votes, so who would I eliminate? I'd eliminate B because B only has 4 first place votes, right? C has 5. So I have to start by eliminating B. So if I eliminate B, so these are gone, these are gone, this is gone. So these right here are now the first place votes for 13 through 16. So who wins that one?
C.
C wins. So C wins that second one. Why does that seem a little strange? What did we say before? Which one did we say was better for A? We said profile 2 is better for A, but yet in profile 1, A won, but just by moving A up higher, we actually caused A to lose, right? That's not a quality that we desire in a voting system, right? That's not something that we want to happen. Now, this is not something that's going to happen frequently, right? It's a rare occurrence, but it is like kind of a glitch in the system. The fairness criteria that this violates is called monotonicity. So it basically says that if you have a winner, then moving that candidate up in someone's list should not hurt its chances of winning. So it shouldn't lose just because I move a candidate up in someone's list. So that's what the monotonicity criteria is. And I should say that I think there's other voting systems that violate this. I think it's not just instant runoff. Okay, here's the second one we're going to look at. Okay, so this one is called independence of irrelevant alternatives. So what I want you to do is just look at apple and cherry. Well, first of all, what's the difference between the two voting profiles? What voters are different?
Last two?
Yeah, the last two. So the first three are the same, right? But then the last two here have decided, I actually like peach better than cherry, right? But notice that all of them feel exactly the same about apple and cherry. So the first three like apple better than cherry, and the last two like cherry better than apple. And that's true here and here, okay? So I haven't changed anyone's opinions about cherry and apple. Now we're gonna calculate the board account winner here. So this is the scoring one, where you give 3 points to a first place vote, 2 to a second place, and 1 to a last place vote. So I'll give you a couple minutes to try and find those board of score winners for each one. Okay, let's try it. So apple is going to get 3, 6, 9, 10, 11 points. Cherry will get 2 for everything, so 10. And peach gets 3 plus 6, so 9. So apple wins. Okay. Profile 2, apple has 11 still. Cherry, 1, 2, 3, 4. Cherry has 8, right? Is that right? Oh.
6, 12.
12. Oh, yep, you're right, thank you. 12. And peach has 7. Okay, so cherry 1. So the thing that's a little strange here is we said no one changed their minds about apple or cherry, and yet in the first one apple won and the second one cherry won. So the only thing that changed is 2 voters changed where they put peach, right? So that's the irrelevant alternative. So peach is irrelevant to apple and cherry, yet putting that irrelevant alternative in somewhere can mess with these other 2 results, right? That again is a result that we don't really, it's a characteristic of a voting system that we don't really want. It's not desirable. It's a glitch. It's not something that's going to happen often, but it can happen. And board account is not the only one that can violate this. So these are just 2 examples of different fairness criteria. There are many more, but I just wanted to show you 2 examples. And you really have to have like a very specific example to show it. You can't just like make any 2 profiles up, and it has to meet a very specific set of circumstances in order to violate these. So it's not something that like if you're using one of these voting systems, it's not something that's going to be occurring wildly, but it can happen. Okay, so I listed a few more fairness criteria here. So there's the Pareto principle, Condorcet criteria, transitivity. There's only one voting system that doesn't violate any of the fairness criteria. Does anyone have a guess as to which one it is? Yep, that's the only one that doesn't violate any, which makes sense because you're not using much info, right? You're only taking one data point, so it's hard to mess it up. That doesn't mean that it's fair. It's still a problem. We all agree that it's problematic, but because it's not taking into account everyone's voices, right? It's just taking into account one person's voice, so it's still a problem. But because I don't have all that information, I can't violate these different criteria. Plurality also is another one that I think doesn't violate as many of them because it doesn't have as much information involved, so it's less likely to have these weird things happen. Okay, so what do we conclude? If dictatorship is the only one that doesn't violate these, well, what that means is we have to pick a voting system. Sorry, this is really bright. Go back. We have to pick a voting system that kind of tells the story we want it to in terms of, like, what do we value? How do we want to take people's voices? And what do we think about power? What do we think about society? How do we want to value people's opinions and put them together in a way that matches our values, right? So we are kind of left open in terms of we don't have a clear answer, right? There's a lot of different voting systems. They have they weigh different things differently. And we can kind of make a decision based on what we feel matches our society best. So I wanted to bring up a couple different voting reform movements. So I'm not advocating for any of these. I'm just bringing them up. These are different ways in which people have said, I think that the way that we do things right now in the U.S. doesn't seem to match what we value as a country. So, if has anyone listened to the Radio episode on ranked choice voting at all? No, if not, I would recommend it. I think it's from 2018, but they posted it recently. But one of the things that they talked about is this idea that the U.S. was coming out of all of these monarchies, right? So the American democracy was a reaction to all of these European monarchies, right? Not that long after, all these monarchies kind of transitioned as well. But they kind of cast this as like, this was a little bit of like a trial democracy, or like it's like a old-fashioned voting system, in that it was kind of the first experiment. And a lot of other countries have voting systems that are a little bit more complex, right? So is there one that maybe meets our needs more? And I'm not saying yes or no, I'm just saying that this is where all of these movements have come out of. So different groups saying, yeah, I don't think that the system that we had before is working. Can we do it differently? Can we find a way that is gonna be better and be more representative of what people think? So Yep, we're gonna talk about that one. Yep. So the first one, I'm not gonna talk a lot about that because it's related to redistricting and it's already happened. So Michigan voters have already said gerrymandering is a problem. We don't want politicians drawing our lines, so our district lines, so we want independent citizens doing that. And in 2020, after the census data came in, the very first Michigan Independent Citizens Redistricting Commission redrew our lines. So they drew 3 sets of lines. They drew them for the House of Representatives, the Michigan State House, and the Michigan State Senate. And that was the first time in our state history that that happened, and we are the 3rd state that has a citizen redistricting commission after, I think Arizona was first and then California. So that's kind of big news. And then the next one on the list is ranked choice voting. So there's a group in Michigan called Rank My Vote that is working on pushing ranked choice voting as an option, or switching to ranked choice voting. And we are far from the first state to explore this. So Alaska is doing this, Maine, I think Vermont. A lot of smaller elections, like California, Minnesota, all have a lot of more local elections that use it. So this is the group that's working on it in Michigan.
Are they looking at like just eliminating the first place vote with the fewest, or eliminating the last?
First place vote with the fewest. Yep. And then the last one is about proportional representation. So fair vote is this organization, and I should say that both of these are nonpartisan organizations. So they're nonpartisan nonprofits. And fair vote is also, so this is more of like a national level. So they are interested in ranked choice voting, but they're also interested in this idea of proportional representation and multi-member districts and single transferable voting. So I'm going to just show you a picture on their website so you can get an idea. Okay, so does anyone know how many seats we have in the state of Michigan? How many seats we have in the House of Representatives? Not the state, in in Congress. 16 was the amount of electoral votes that we had. So if you take 2 of those off for the Senate, it was 14, but in 2020, we lost a seat because even though our population grew, it didn't grow as much as other states. So we are now at 13 seats. So our current map has 13 districts in it. This would be an example of what Fair Vote is proposing. Not this exact one, it's just an example. So 3 districts. This district elects 3 seats. This district elects 5 seats. And this district elects 5 seats. So that's 13, right? So each district elects more than 1 person, right? So the idea is, let's get away from a winner takes all. Let's split it proportionally. So I'm going to give you an example of how this would play out. Okay, so there we go. Okay, so districts are larger and they have more representation per district. So more seats per district. The candidates have to pass a vote quota to become one of the, I should say not candidates, to win one of the seats. That's a typo. So if you just have 1 seat, the quota is 50%. So this is very similar to ranked choice voting, except you have multiple seats, right? Ranked choice voting, you have 1 seat that you're going for, and you have to get more than 50%. If you have 2 seats, the quota is 33%. So you have to get more than 33% of the vote. If you have 3 seats, the quota is 25%. 4 seats, and it goes down and so on. So if you want to know the formula, It's this number of votes. This is for the number of votes, not the percentage, but number of votes over number of seats plus 1. So that's like your threshold that you have to hit. So if you have 1 seat, you have to have just over 50% of the votes. Yeah.
Now, with this, are you, each voter is allowed to vote for one person?
No, you're still ranking.
Oh,
Yep.
okay, right.
It's very similar to ranked choice voting, except it gives you a result that fills all of the seats, not just 1 seat. So you wouldn't use ranked choice voting for this because it wouldn't work because you got a bunch of seats you have to fill. But if you're just filling 1 seat, it's basically the same as ranked choice voting. So this is like the souped up version of it if you have multiple seats to fill. So let me walk through an example. So let's say you have 1,000 votes and you've got 3 seats to fill. Okay? And we've got 6 candidates. So let's say that this is initially how it plays out. Let me make this a little lower. And everyone is ranking the candidates. So you're ranking them, and it works just the same if you're familiar with kind of, because I gave you the theoretical version of how ranked choice voting works, but in practice you could just not vote some candidates and you could not rank certain candidates, right? So you can do the same thing here. So the ballot looks exactly the same. So let's say that this is the number of votes that we get. So this is my 250. I should say that's my cutoff here. To get a seat, I have to get more than 25% for 3 seats. That's my threshold or my quota. So let's say A is at 120. B is at 260. And 192 for C. 200 for D. 168 for E, and 60 for F. Okay? This is I'm just looking at the first place votes. So B has already hit the threshold, right? B has already hit that. So if I were to do like a bar chart, it would be something like this. Right? So just like with ranked choice voting, you start eliminating, right, to get more seats. But what we do with this one is I'm actually going to take the surplus seats from B. Okay, so how many surplus seats do I have for B? 10. And I'm going to take those 10 and I'm going to redistribute those because those are essentially wasted votes, right? Because they're not, if you have a bunch of extra seats, they're not helping anyone win. Okay, so I take these 10 surplus, and I'm going to go to their second choice vote, just like we do with ranked choice voting. Now, when I first saw this, I was like, yeah, but who are those 10 voters, right? Because there's 260 people. Who are the 10 voters I'm choosing? You don't actually take 10 voters. You take a percentage of that 260, and you look at what percent had A as a second place vote, what percent had C as a second place vote, what percent had D, and so on, and you take that percentage of the 10 and redistribute it. So let's say, let me use a different color. So let's say of these 260 people, 10% of them has A as their second place vote. 30% have D as their second place vote. 50% have E. And 20% have C. And 0% have F.
10%.
Yeah, something.
Is that too much? Oh, it is too much. Okay, I'm gonna say 0%. There we go. Okay, so A doesn't get any extra seats or votes. F doesn't get any extra. D gets 3 more. Now 203. E gets 5 more. And C gets 2 more. And then B is just done, because B has a seat. Okay? Okay. Now, if distributing those extra seats gets someone over the threshold, then they fill another seat. But I haven't done that yet. So any thoughts about what we eliminate next? Yeah, we're going to go with the candidate with the least amount of votes, just like with ranked choice voting. So F is going to be knocked out. That's a lot of votes to redistribute. So we're going to do the same thing. We're going to look at the percentage of votes, and it could potentially not be the second place votes, right? Because it could be further down the line, but it's whatever comes after F in each of those lists for each of those voters. And in this case, I don't have to do a percentage because it's all of the voters are being redistributed. So let's say 30 of them have D next. So 30 go to D. "24 go to C, and 6 go to E. And none of them have A next in their list. Okay, so let's see what happens then. So then D is at 233. C is close, 218. E, 179. Yeah. And then F is gone. Okay, so D was the next one to hit that line, so,
Is 250 still our threshold?
oh, it is, you're right. Did I put my number? Yeah, you're right. Okay, so I'm gonna have to redistribute, right? So who gets knocked out next? A, yep. Let me knock this back down. A, so A is gone. Well, let me leave it up so we know how many we have. 120. Okay, so A gets knocked out. So let's say that 50 of these voters have D next. 60 have C next. And 10 have E next. Okay, so now C and D are going to be above that threshold, and they're going to fill those last 2 seats, right? So you essentially keep doing that until you have enough candidates to fill those seats. So it's similar to ranked choice voting, but you've got the multiple seats to fill. So this is kind of what Fair Vote is proposing. They've been proposing it since like 1992. It's been in the works for a long time. And this is also what is used by many, many countries around the world. You have, districts where I guess I should say the other thing that sometimes happens is instead of voting for a candidate, you vote for a party, right? So in countries where they have many more than 2 parties, you might be ranking your parties, and then the parties just fill the seats with who they want from their party. So that's kind of variations that you'll see. Okay, so I think that's all I had. Let me make sure I don't have another slide. Oh, just questions. We got 3 minutes left for questions. Does anyone have questions? Yeah. Go ahead.
Oh, go ahead. Go ahead. I was just curious how the districts are proportioned, like it was 3, 5, 5, as opposed to 4,
Yeah, that's a good question. I don't know if it has to do, if you look at the map for Michigan, I would guess, because when you draw districts, there's a lot of things that go into drawing a district. So you have to take into consideration like communities of interest, you want geographical location. There's like 8 different things that in Michigan we take into consideration, compactness, things like that. And this is just like a suggested educational thing. It's not like an actual scenario, but this is a big chunk of Michigan, and it just has 3 seats because there's not a lot of people there, right? So, yeah, I would guess that it's probably related to that. Yeah.
So as n increases, the probability of committing an error increases, right? Just getting the count accurate. What's your thoughts on these different voting methods and the probability that there will be a mistake because n is so large?
Well, I guess I can't say it's like, I don't think it's likely that we would have mistakes. A lot of countries use this regularly and they don't have an issue with like major.
Well, so the law of large numbers says as n approaches infinity, the probability of committing an error will also approach 1. So that's what it says. As the count gets more complicated, tracking it correctly gets more complicated, right?
Yeah, I'll just say this. Other countries use it without an issue.
Without an issue?
Yeah. We don't have to debate it, but yeah.
What does it take to change to this voting system?
Well,
Simple majority?
There's a bill so Fair Vote has a bill that they've proposed. They proposed it years ago, so it hasn't had any movement on it. But that's basically what they're using is like, can we get this bill passed? So if you want to like look at ranked choice voting in Michigan, I would look at the Rank My Vote website and see what they have going on. Yeah. It's a massive, like the Fair Vote idea of switching to this type of multi-district system, that's a massive thing, right? That's a huge change compared to what we've been doing. So that's not something that can just happen like that. But there are people that have been working on it for a long time. Yeah. Yeah.
So is Rank My Vote pushing for it to be a ballot proposal?
That's my understanding, yeah. Yep.
So that people would vote on it directly if they want to
Yeah.
implement ranked choice vote?
Yep, and that's how.
Petitioning will be starting this summer.
Summer, okay. Are you involved with Ring My Vote?
Friends are.
Okay. Yeah, that's how the Michigan Independent Citizens Redistricting Commission came about. And my understanding is that a lot of the people that worked on that are also working on the Ring My Vote. Yeah. And again, I'm not saying I'm advocating for any of these one way or the other. I can't, but I'm just sharing it. I know, this is a time when people are thinking a lot about elections and voting and social opinions and things. So this is a good time to be thinking about it. Yeah.
Are the probabilities for errors in voting for any of these systems high or low?
Well, that has less to do with the system itself and more to do with like how are you the mechanics of tallying the votes.
So if that's the case, wouldn't humans in general like make errors a lot of the time, so most of the structures in the systems aren't really that fair?
Yeah, I mean, I would say a lot of these are probably not being done by hand. There's probably computer systems that are doing the voting, yeah. Which humans write the computer systems, but yeah.
The more visible the counting is, the more things can be weighted if we don't know it.
Yeah.
That's where there's question in the voting
Yeah.
with the technology.
Right.
Because can't technology as well like still be wrong? Like it's small, but the probability is still there.
Yeah. Any other questions? Thanks for coming out.